Okay, in this video we will be looking at 4.3 correlation coefficients and outliers. Looking at roller coasters, a recent survey counted 1,797 roller coasters in the world, 734 of them in North America. I think most of us have driven roller coasters, so most of us will be able to relate to some of these statistics that we're going to be looking at today. One of the big questions we're going to be looking at is which roller coaster variables do you think strongly related to the top speed? So what makes a roller coaster go fast? And one of the definitions that we're going to be looking at is this thing called a correlation coefficient. Make sure you write this down in your notes. A correlation coefficient is a decimal between -1 and 1. So when the points lie close to a straight line, okay, when the correlation is strong, the coefficient is close to -1 or 1. And we're going to talk more about that. If the correlation is strong and the slope is negative, then it's going to be a -1. If the correlation between the data points is really strong and it's positive, then the correlation is going to be 1. Okay, so here it says it again. Make sure you write this down in your notes as well, right? That first one is what I just said. And then the second one, if the points do not cluster close to any line, they have a correlation coefficient that's almost 0, meaning they don't correlate at all. So it's either 1 could be representing 100%, it's a strong correlation, or 0, meaning there's no correlation. Okay. All right. So the graph below has a correlation coefficient of 1. What do you think a correlation coefficient of 1 means? So go ahead and answer that question the best that you can. And then, so pause the video and then write your answer in your notes, what you think the correlation of 1 means looking at this graph. Okay, so you should have said that a correlation of 1 means that there's a perfect linear relationship or a really strong linear relationship between the two variables, and it has a positive slope, right? So strong linear relationship between, if this were x and y, whatever your two variables were. And then also it is a positive slope. We should have those two things down. It says if it's a 1, I should be able to draw my line through here and touch every dot or almost every data point on that graph. All right, so go ahead and use that information to answer 2, which says which of the 6 scatter plots below has a correlation coefficient of -1, and then answer what do you think a correlation of -1 means. Pause the video and try this one on your own, and then come back and see how you did. Okay, you should have graph B has a correlation of -1, because that's exactly like the one that we did that has +1, only it has a negative slope. So if it has a correlation of negative slope, this is going to be true. It's got a strong linear relationship, but now instead of a positive slope, now this has a negative slope. Okay, so positive or a strong linear relationship and a negative slope if the correlation coefficient is -1. Now, on number 3, match correlation coefficients, those correlation coefficients with the other 5 scatter plots. Explain your reasoning. So go ahead and match these up. Which ones do you think belong with which graphs? Pause the video and come back and see how you did. Okay, so if we look at the other graphs and the relating correlating coefficients here, the first one is going to be 0.4. We already did B. On C, you should have 0.8 because the points are more closely stacked, or related to each other, but not quite perfect. And then the next one is going to be negative 0.4 because it looks like A, except they're correlated in a negative relationship. And then E is going to be negative 0.8 because they're close, but in a negative way. And then F is 0.0. There's no correlation at all between those points. Moving on. So on the next one, when you inspect a scatter plot, often you are looking for a strong association between the variables. So we have the scatter plot below that shows the relationship between the top speed of a roller coaster. So you have the top speed of a roller coaster and its maximum drop. So here's its maximum drop and here's its top speed. Okay, so again, independent, dependent. The maximum drop right here, this is your independent variable, meaning the top speed is going to depend on your maximum drop. So as you're answering these questions, please keep that in mind. Okay, the blue dots represent steel frame roller coasters, whereas the pink dots represent wood frame roller coasters. Go ahead and answer these questions 1, 2, and 3, and then come back to the video to see how you did. Okay, and the first one, suppose you drew a linear model for all the data in the graph. Could you use a model to make an accurate prediction? So we can answer that question by trying to draw a line of best fit. All right, so our line of best fit might look something like this. All right, and when we look at that line of best fit, or even your line of best fit, this doesn't necessarily go through the middle, maybe even something like this, that red one. Okay, so either way, those try to go through the middle, and they pretty much, they are accurately depict that information, those data points from beginning to end. Right around in here, it's a little bit confusing, goes up a little bit, but it is a linear relationship. We can obviously see that. So yes, it would, we could create a linear model to help us predict that. Number 2, the correlation coefficient. Is the correlation coefficient closest to -1, -0.5, 0, 0.5, or 1? Well, we know it's not negative, and we know it's not 0. Okay, now the only ones are 0.5 and 1. And it's not going to be 0.5 because it's actually close, pretty close correlation. So the best answer here is going to be 1. Whereas if you actually mathematically figure this out, the answer, the correlation coefficient is 0.8. So that is closer to 1 than it is to 0.5. Now we are not figuring this out mathematically. We're looking at the data and trying to estimate what that correlation coefficient is. And it's closer to 1 than it is 0.5. And then on 3, is the maximum drop of the roller coaster likely to be one of the causes of the top speed? Absolutely, right? Because if you look at the maximum drop right here, as the maximum drop increases, like this one, these are increasing, so does the top speed. Right, so there's definitely a correlation to maximum drop in top speed here. Now let's look at similar data. We have this scatter plot that shows the relationship between the top speed of a roller coaster. So you have the top speed of a roller coaster right here on your y-axis and its track length. So right here is its track length. The pink dots represent wood frame, blue dots steel frame, just so you can get an idea of the difference there. Go ahead and answer these questions 1 through 4 and then come back to the video and see how you did. So try to answer these questions on your own and then come back to the video to check your answers. Okay, and the first one, it says, suppose you drew a linear model. So let's draw a linear model. See if I can use this. And we'll just try to kind of draw through the center here. Let's make it pretty thick. So if we try to draw through the center there, that's kind of going to be what our linear model looks like. And it says, could you use the model to make an accurate prediction about the top speed of the roller coaster given the track length? Now, I would say on this one, no, because you do have a lot of outliers. You have all of these points way outside. So you could get an idea, but I would not say that it's a very accurate depiction with a lot of these data points. It does have a positive correlation. So in number 2, estimate the correlation coefficient, right? We know that it's not negative 0.0, or sorry, -1, -1/2, or 0, because there is a correlation. But in this case, it's not close to 1 because it's not a strong correlation. So it's actually closer to 0.5, okay? And 3, is the track length of a roller coaster likely to be one of the causes of the top speed of the coaster? Why or why not? Since there is a positive correlation, since there is a correlation, the answer to that question would be yes, even though it's not a strong correlation, it's not a strong relationship between the two, there is a relationship between the two. So it does, track length does affect top speed in some way. And then 4, computer and calculator data analysis tools can take data pairs like those plotted above and calculate and extract correlation coefficients. Use the tool you have available to find the correlation coefficient for the sample of track length, top speed data in the table. And actually for this one, we're going to go ahead and skip this one because we don't have access to that computer program. We have this data, but you would need to input that into a computer program and it would measure the distances between to come up with that coefficient. So we're going to skip number 4 and on part C and move on to D. This says the scatter plot below shows the relationship between the top speed of a roller coaster and the ride time. The pink dots represent wood and the blue dots represent the steel frame roller coaster. So the two variables we're comparing this time is top speed and the ride time. And we're looking if there's a relationship between those two things. On number 1, go ahead and answer numbers 1, 2, and 3. We should be able to answer all of these. Answer 1, 2, and 3, and then come back to the video to see how you did. Okay, on number 1, it says, suppose you drew a one linear model for all the data in the graph. Could you use the model to make an accurate prediction about the top speed? Now, these points are even less tightly clustered or correlated than the ones before. Like if we drew a line through the middle, you notice how they aren't as closely related as either of the ones that we've done previously. So we could do a linear model, but it would be even actually less accurate than before. Okay, so a linear model would not be reliable, but if you're going to do a model, linear would be the best out of any other option that we have, because they're not inversely related either. So we're going to answer that question for number 1. Number 2, estimate the correlation coefficient for the top speed. So in number 2, the correlation coefficient, we know that it's not negative because left to right, the points tend to increase. They do have a positive correlation. We know it's not 1 either. So I would say it's somewhere between 0 and 0.5. And it's probably actually closer to 0 in this case. There's very little relationship between the ride time and the top speed. So on 2, I would accept either 0 or 0.5. It's somewhere in between. It's probably closer to 0. Where mathematically, it's actually 0.24. So that's why I would accept either one of those. Again, we are not finding this. We don't have the tools to find that right now. Number 3, suppose most of the points of the scatter plot cluster near a line, with only a few that don't. The points that lie outside the cluster are called outliers. So in this case, some of these would be your outliers. They're way outside of the typical data points. So use the graph above, find each point, then decide whether the point's an outlier. So you're looking at point A, if it's an outlier or not. A is not an outlier, so 1.75 is about right here. And then if you go up to 50, so that's right in here. You notice that's in the cluster with all of the other points, so that is not an outlier. Okay, if you look at B, however, 0.3 and 80, so 0.3 is about right here, go all the way to 80, and that's a point that I circled right there. That is an outlier. Okay, and if we look at the other ones, C is not an outlier. D is an outlier. So this one was yes. D is an outlier, so 0.28, 120. So that's this one all the way up here. That also is an outlier. E and F are not outliers. Because if we look at F, 110 right here, that's that point right there. That's pretty close to the line. That's actually on the line that I had originally drawn. Then G, use the scatter plots in question C to find two outliers on that graph and estimate their coordinates. So we're coming back up to here, right? So the two outliers I would choose are this one and this one. And this one has coordinates of, let's say, 2,700. And the y is 120. So you would just need those coordinates. So that one is 2,700, 120, and this one is going to be about right there. So that's 15. So let's say 1,300. That's your track length, feet, and 100 is its top speed. Okay, so those would be two of the outliers for that question there. All right, so let's do another one. Different data points that we're comparing. So we have the scatter plot, and it shows roller coaster ride. You're comparing the age of the rider to the number of those riders at that given age. In the first question, it says, suppose you drew a linear model. So again, we're answering the same similar questions. You're drawing, if you want to think of a line, don't draw in your book, but think of a line that goes through that. That's our linear model, because it says to draw a linear model. Okay, go ahead and answer these questions 1, 2, 3, and 4 to the best of your ability, and then come back to the video and see how you did. Okay, to answer the first one, we have our linear model. Could you use the model to make an accurate prediction? So in this case, yes, that line that goes through, the points are all pretty closely clustered in. We do have a couple of outliers here, right? And that's because you're looking at 15-year-olds here that may not ride some of these. So it takes an older person, probably up to 16 or older, to ride some of these rides. But yes, this would be an accurate depiction of the age of the rider and how many riders you're going to have at that age for that day. And then 2, is the age of the riders on a roller coaster likely to be one of the causes of the number of rides? So yes, on number 2, because we can see that there is a strong correlation. And then number 3, estimate the correlation coefficient. So again, we know that it's not a positive because the slope is actually negative of my model there. And we also know that it's not 0 because there is a pretty strong correlation. So we know that it's either going to be -1/2 or -1. And I would say that it's actually closer to -1 because it's a very strong correlation. And the actual answer, if you were to mathematically go and figure out, which we're not doing right now, we're estimating the correlation coefficient is -9.4 or -0.94, which is actually a really strong correlation. Then on 4, are there any data points outliers? Yes, there are a couple of outliers. I've circled some there. So let me highlight them. Here, here, and here. Those are outliers. And that looks like 14 or 15-year-olds. Number of riders would be 45 here, 60 here, and 70 here. So if we're coming up with the where they're at, the coordinates, that would be, I would say all of these are 14-year-olds. And you have 45 as the number of riders, and you would have 60 riders, and then you would have 70 riders. And a couple other outliers are out here, where you have, let's say, a 72-year-old, a 77-year-old, 77-year-old, and then an 80-year-old. Right, and then if you look at the number of riders, it's barely any. Like you had maybe one 72-year-old, one 77, and or let's say these are two, and that's one. Something like that. All right, so your answer should be similar to the ones that I have here, but they don't have to be exactly, but they have to be pretty close to what I have here. Okay, and the last one. Is it possible to have a correlation coefficient close to -1 or 1 with only a few outliers? Absolutely. As we can see here, in this case, we have a few outliers. But if we have a lot of outliers, like here, I would say all of these, and there's not many outliers below. Maybe some of these could be considered outliers, but all of these, so you have lots of outliers. If you have a lot of outliers, it's going to be a less strong correlation. So the answer to F is absolutely. You can have a few outliers. So make sure you explain that in your own words as to why you can have a few outliers. And it still have a correlation coefficient to -1 or 1. Okay, that's all for these notes for 4.3 correlation coefficients and outliers.